it. Hello, everyone. Thank you so much for joining us for today's AIAA Los Angeles Las Vegas section town hall meeting. So we are a great pleasure to have our distinguished speaker, Mr. Dennis Liang, here. He's a great expert for the space satellite. So you'll learn a lot from his long years of experience. He's trying to share the wisdom with you. Before we start the program, just a few for logistics. Today, because we actually didn't pay for the cleaning fee, so if you please don't have the food in the room, if you water, bottled water, but don't store the trash inside the room. There is a cafeteria right out there with the red tent, so you're welcome to get coffee or food, after the event. So the presentation will start shortly, and it will last around slightly over 12, and you're welcome to stay chat with the speaker. And the other thing is this meeting is being recorded, as you just heard. The microphone is actually on this very nice TV. Then we highly appreciate Longdale Library. You can see this beautiful room. Really appreciate their help and the support. And the other thing is that if you are not yet a member of AIAA, we have brochure behind it. Please contact us. Contact at AIAA-LALB.org, or you can look at www.aiaa.org, that's national, or look at AIAA, www.aiaa-lalb.org for the local chapter. So if you have any question, my name is Ken. I'm the chapter chair, section chair for the Los Angeles Vegas section. We have over 1,000 members in this area. Overall, AIAA it has 30,000 members. So some of you are already members. And actually next week, actually tomorrow morning, I'm going to Las Vegas to support our section booth in the AIAA Ascent conference, which is the leading conference for space, economy, and technology. So our distinguished speaker, Dennis, is not only he's very experienced, he formerly worked in Northrop Grumman, satellite operation, and is in the leadership position. Formerly before that, he was also working in the now called the Armstrong, but it should be Dryden, the NASA Research Center, doing hypersonic stuff. And now he's in Daibashi Consulting. He's a founding member. He's a founder of this great organization. So we have learned a lot from him. So today you will hear from him, and also 2 weeks from today in the same. It's his long years of experience digested, and he want to throw back to the community to help everyone. And please stay in touch with him. And without further ado, let's welcome Dennis.
All right, thank you very much, Ken. I appreciate it. Wonderful introduction there. As Ken has said, my name is Dennis Liang. I've been in this industry for over 24 years in a number of different roles, from technical to management, all the way to even into construction of building a brand new factory. So we're going to talk about today is really the spacefaring ecosystem. What does it mean? How does that have further ramifications to just about everybody here on the planet, right? In every industry. So when we look at what is an ecosystem, we're all familiar with an ecosystem here on Earth. It's going to be really the same thing. Everything that you interact out there, the planets, humans, anything that you go that's related into an environment is part of your ecosystem, right? And one of the important ones is going to be, what do we build to get us out there? What are we going to use to live up there? And these are the spacecraft, the satellites, man-made objects that we put into space. We're very familiar with satellites, been around for many, many years. We're now moving more into a reusable spacecraft, so you'll start to see a lot more of that. And then in near future, hopefully we'll start to see more space stations that allow, besides researchers and government employees on there, that you actually allow regular citizens. And one of the major things that's really driving this is we have to look at is resources. There's pretty much an infinite amount of resources out there if you really think about the number of planets, the number of asteroids out there, that there's more stuff out there that's ever been mined in the history of Earth right now, right? And it can change pretty much the economy of this whole planet. But in addition to that, we also have to look at the legal and regulatory compliance portion of this. Over the years, there's hasn't been too much of it, other than just what the governments themselves mandate for them. But they're good at policing themselves, so they don't really have to worry about too much. But when you start to look at the broader picture of companies starting to get up there, companies can do whatever they want as long as they make a profit. So then you have to put a little bit more regulatory compliance on there. But we'll talk a little bit about that later down the line, that you have to strike a balance. Too much, you stifle competition. Too little, you might have accidents and incidents that might actually kill this industry. So, how do we increase our market share in this? A lot of this is you have to adapt or you will be left behind. There's a lot of competitiveness. Everybody has now heard of SpaceX. If you haven't, I'm not sure where you've been, but SpaceX has come onto the scene and they've disrupted everything. ULA used to be the big players in the group, right? They used to own everything, monopolize, charge whatever they wanted, made huge profits. Government just paid it. They had no other choice, right? SpaceX came along, pretty much said, hey, we can do it better and cheaper, and they did it, right? And so now ULA is starting to rethink how they're doing stuff. And because of this, you have other companies, right, that starts cropping up to get into the small sats, medium sats, different kind of launch vehicles versus just one set of pretty powerful rockets that has to bring up a lot of payloads, right? So now you've got specific rockets that bring up small sats, CubeSats, and so on and so forth. So there's this expanding market now. And because everything has been brought down to such a cheaper level, that it allows these companies or these organizations to actually put their products into space. So we have to look at this economy. Because everything is coming down in price, a lot of these other companies that never had the opportunity, because most companies in the United States are small to medium-sized companies, and they do not have hundreds of millions of dollars to do one launch. So now, because the price is coming down, you have smaller providers coming up with different capacities and payloads. You can see the space economy is going to increase exponentially.
Keep in mind, if you're speaking to the audience here,
Oh,
your volume will be reduced.
Oh, my bad. I'll speak this way.
Either this way or over there.
Okay. So,
Thank you.
Can they see me? Oh yeah, they can still see me. Okay. So, because of this additional access, a lot of these companies now have the opportunity to diversify, meaning that some companies that used to provide some space products to the industry, they view it as more of a niche. Right? Oh, this is something we can do for you, so we'll just kind of do it off to the side. But it isn't something really baked into their strategy or overall vision for the company as, hey, this is an area I want to grow and be a leader. And so these are opportunities that these companies can really look at and either adapt or fall behind. And give you examples of that. You look at SpaceX was #1, right? You look at Tesla as #2 for EV vehicles. All these other manufacturers are trying to catch up, trying to dump out all these EV vehicles now, right? They're all trying to catch up. You can also look at any other industry in the past, automotive, back in the 80s and 90s when the Japanese were trying to put new processes of how they build vehicles, and American automotive manufacturers was, no, we don't care. And what happened? All the share went over to Asia, right? They lost almost everything, almost went bankrupt. Right? And so this is where adapt or fall behind. So it really starts with research and development. This is not really so much for the large companies like the Northrops, the Boeing, all these enormous multi-billion-dollar, trillion-dollar companies. This isn't really for them. They do have a lot of research and development, but these are actually for companies who are not necessarily always thinking about the space industry. Okay, so these are companies like food packaging. These are companies like transportation and logistics, right? These are companies such as healthcare, medical. There's a lot of different industries that need to go into supporting this new space industry. Um, in addition to these private companies, the government themselves also have to start looking at how do we manage everything that's going on up and down and the economy up there. If you don't have it, it's going to be chaos, right? Because something that's okay may not be okay down here is okay up there, and the rules don't match up, then we're going to have problems, especially from a compliance, regulatory, and or liability standpoint, right? So the government and or whatever issuing bodies or organizations will really have to start looking at how do we really start managing this. Now, a lot of these companies right now, or I'm sorry, a lot of these countries and or organizations are starting to pump money into these into the space organizations because they realize that if they don't get a part of the pie, they will be left out completely. And this is just a small portion. You can see even the UAE is pumped in, $817 million, in the next year to try to get their system up and running. I mean, NASA's 45 million for small businesses, but they do have a larger budget than that. Japan themselves, 80 million to small businesses. Even in Europe, you got 65 million pounds being dumped in. Like you said, this is just a small portion of what a lot of these other countries are really pumping into the industry to kind of help these small businesses kind of open up the market share. So when we speak of market share, you can see here, right here between 1960 to about the 2005 range, everything here is pretty consistent, right? Government launches here and there, little things. They want to do, the governments kind of self-police themselves. It's more for research, government development, so on and so forth. So there really hasn't been much of a need to address regulatory standards and such, right? Because again, they can police themselves. But now you start to look at about 2005 on up, to about 2030, because the cost per launch has gone down and will continue to go down. A lot more companies are now available to go in and access space. So what does that mean, right? That means that when these companies start to put products up there, they start to mine resources, there has to be some rules on what they do and how they do it, right? From a safety standpoint, either personnel, right, or traffic management standpoint, and so on and so forth. So there's a lot of different things that the government is going to have to start to address, right? You look at when air travel really took off, decades and decades ago, when there really wasn't air traffic management. But as it grew, you can see the enormous organization now that's there just to manage air traffic control. And it's going to be very similar when we get into space as well. Uh-oh. Ken, did you do something? It's not moving.
No, I simply just hide the
Oh.
Maybe it's a distance. Next time.
Nope. Oh, there we go. Okay.
It's okay?
Yeah, there we go. So let's just take the health industry. There has been a lot of research in the effects of humans in space, but that's really been done by the government organizations, NASA, right, the US government, so on and so forth. And that is really to take care of their astronauts who are highly trained, very physically fit, right? Ideal people to go into space. When you start opening up the market and you have regular people to go up there, right, you're gonna need a lot of this help, right? That's why we have such a big medical industry here, is that a lot of the people that's going to be living up there is not going to be trained like astronauts, not going to be 100% physically fit like they are, mentally and physically, right? And so a lot of these effects right here will have to fall down to who? The medical industry, right? And so the medical industry themselves will now need to start to evolve, right? You look at some of these regulations and standards, JACO, OSHA, medical schools, and associated curriculums. All of these will have to evolve in order to teach this type of medicine in space. It will be a little bit different. Equipment will be different, right? How you interact with things will be different. Things that you're completely used to here being, oh, I can do surgery on the ground because there's gravity. And in space, everything's going to be floating around, so you're going to have to rethink how you do certain things. So techniques will be completely different. And so this is where medical schools will have to start looking at, oh, how do we teach? What should we teach? What is safe and what is not anymore? And then what are the health standards that a medical facility in space should be, regulated to versus here on Earth. Right? So this right here can be applied to just about all the industries that we're going to talk about a little bit later. So we have to see things for what they really are. What are the opportunities? And really, it is a leap of faith. Most everything that we start in new industries is going to be generally a leap of faith. So let's take air travel, for example. The very first time, there's always a whole bunch of naysayers. It's never going to work. It's just for the rich people, so on and so forth. And so, those people will always try to kill whatever the new idea is. But let's just say it starts to take off. We all know air travel very well. So what are all the different kind of industries that crop up? Parts manufacturing, commercial cargo, aircraft leasing, maintenance, disposal, fueling operations, airport development, security screening, air traffic control, retail, ground transportation, insurance, and risk management, right? That's just some of the things at the very first level that you have to look at that crop around air travel, right? Oops, backwards. Level 2, catering services, entertainment, connectivity, marketing, clubs, lounges, and so on and so forth. Now that it's become more of a everyday occurrence, how do we get more people involved, right? And then when you get a little bit further down, air traffic control software, even fashion, right? Now that's a big thing. Oh, what is the next fashion? What are all the uniforms going to be for this new airline for the year? So you even have fashion, logistics software, retail software, robotics, so on and so forth, and it just continues on, right? And so if you look at this kind of a top level roadmap, you can apply that to space travel as well, right? In the space economy, all these things will crop up. And how do we utilize what we've learned here on Earth in space? There are some things that we can mimic and use as is, but a lot of it we're going to have to modify and or build brand new. Right? And like we talked about before, the latest innovations is take electric vehicles, for example. When all these EVs came out, where we're going to charge them, right? Now we have superchargers everywhere, right? And you have all these other companies called EVgo, starting to put out their chargers. And so you can see it starting to expand. In real life today, you're living it as we go. All these new opportunities and space exploration, the second expansion with SpaceX kind of kicking it all off, right? For those who are very familiar with the startup industry, you can see all these brand new rocket companies come up, all these companies starting to pitch about space stations, all these companies starting to pitch about all these brand new ideas that they can do in the new space economy. So for the next couple of slides, we're going to talk about heavy industry. This is probably one of the big things in terms of what we can really get out of space, right? One of the easiest return on investment opportunities is mining, right? And with the largest return on investment. There's going to be a number of different things that we have to take into account. There's the resources that you can gain from it. There's the technology that you can develop from it, but there's also a very big geopolitical side of all this that you do. Okay, so let's look at the resource and technology side. If you go and you start mining, abundance of materials out there, right? There's asteroids that have more gold than has ever been mined on Earth in its history, right? So as you can see, there's so much raw resources out there that it's really for the taking. Water, you can mine for water up there. There's a lot of new vehicles that will have to be developed to do the mining because you are in a zero-G environment or low Earth gravity environments. So you'll have to take all of that into account. How do we get it back? Do we even get it back? Or do we process it there, right? Other things that we have to take a look at. Is it going to be manned, robotics? We're going to have new extraction technologies, probably based on extraction technologies that we've done here on Earth that we've learned, but with, of course, some modifications because you are in a new environment. And this is going to some of the regulations, new safety and emergency equipment. What does that look like, right? Over there, you're going to need life support systems. Over here, not as much, right? And the life support systems here is going to be vastly different than when you're in space. So what does that look like? What are the rules, right? Do we use the same rules that NASA uses? Because if we do, no one can afford it, right? Because they're so cumbersome and so many rules out there. So we have to look at what's the balance, right? New refinery technology and methods. Do we refine in space or back here on Earth? Again, everything was designed to be in a 1G environment. So if you're on low Earth gravity or in zero-G environment, what does that look like, right? Things are floating around now versus underground on a conveyor belt. Who knows? New ways to think about it. Let's look at the geopolitical aspects. So imagine you bring down all these precious metals and you just pretty much blow apart everything that we know of how precious gold is, and it's not anymore, right? It could be just another rock on the ground. Those are things that we have to look at. Now, it could be that because we are exploring in space, we need a lot more of it, and so maybe we can maintain this. Who knows, right? But this is just things that we have to take a look at. You have a brand new marketplace for all of these things, right? Either here on Earth, that you can sell products that you get from space down here and or utilize it up there, right? So now you have a new marketplace. You have brand new job opportunities, and it will stimulate economic growth. Every time that we've always had a space explosion in terms of exploration and or interest in using space, then there's always been some sort of economic growth with it, right? If not just technological growth. Because a lot of things that we're used to using today was really based off of the space program. Oops, sorry. And this is probably going to be one of the biggest things right here is you're going to be redefining economic politics, right? Let's just say, when we get to the next one, actually, let's just go ahead and go to the next one. When you get to energy, we're also used to, we need fossil fuels and all this. So we're beholden to countries that have the most of it. So now when you're independent of it and you no longer need them, what does that look like? Right? Things that we do, our policies that we make here will be completely different. And so these are things that we have to really look at, right? From an energy standpoint. You go into space, solar energy. If we're good and we know what we're doing, we can have pretty much limitless solar energy up there, 24/7. And so what does that look like down here? How do you get the energy back down here? Use some of it here, use some of it for space when you have all of these other industries going on. This in itself is going to advance the solar energy capture technology, right? Better solar cells, maybe new ways of capturing the energy, right? Because when you're a company who is driven by profits, you're going to want to continually do better so you get a higher ROI, right? That's not necessarily NASA or government's stake on it. They just want to do it for pure research. So cost to them doesn't matter as long as the government keeps giving them money. But private industry, they're driven by their ROI. That's what it's going to end up being. So when the ROI is there, they're going to continue to try to develop, squeeze out the technology as best they can to get a higher return on profit. So there's a lot in manufacturing right now that's been happening for quite a while in space. There's been a lot of experiments of how can we manufacture in space. There's been a lot of talk about can we even build a satellite modularized in space with little to no interaction with humans. Can we 3D print in space? There's been missions up there to test out that technology, but it will be big changes to the manufacturing methodologies. We know what the ideas are down here. It's just how do we apply it to space? And when we look at a lot of these industries, and the same thing when we build satellites is everything is meant for 1G environment, right? Let's take satellites. Go back to satellites for a little bit. A lot of people sometimes ask us, why do we test so much on satellites, and why does it cost so much to build satellites? Well, let's compare it to airplanes. You want to test as you fly for the most similar environment that it's going to see. And so what does that mean? You build a prototype, you fly the aircraft. For a satellite, that's not that easy. Once it goes, it's not coming back. So we have to simulate that environment here. Everything we build on a satellite is meant for low gravity environment or no gravity environment, microgravity environments. So that means that whatever arms are deployable, whatever opens up, those are very weak. It's not designed for a 1G environment. And so we have all of these offload fixtures to offload the weight when we open up the arms and do deployables and so on and so forth. So all those equipment have to be built, designed, and there's cost that's involved with it. So how do you simulate a vacuum environment? We have to put it in a gigantic chamber, suck out all the air, do our testing in there. And all those chambers cost hundreds of millions of dollars, right? And those tests are not cheap. And so that's the only way we can test it here. And so that's why things cost more. So now, if you were to build it in space, you don't need those systems because you're in the environment it's meant to operate in. So you can open and deploy something, and that's the environment it's meant. So you can cut off hundreds of millions of dollars of support equipment because you're already in the environment. You don't need those kind of things. And so that's something to think about here in the manufacturing world, right? Now, that's a bonus for products that are meant to be in space, but for techniques that were pioneered here on Earth, it becomes a little bit difficult in space, such as you take 3D printing, for example, right? 3D printing, whether it's powder or fused deposit modeling, FDM or resin printing, that's all designed for a 1G environment that's holding materials down while you're lasering or, so on and so forth. But now, if you're in a low gravity environment, it's all floating everywhere. How does it work now, right? And so there are things that will cost more, and there are things that will be cheaper. But as you have more research and development, eventually that will come down, just like everything else. And let's look at the geopolitical aspects of this as well, right? Manufacturing footprint, redistributed. Now, when we do a lot of city planning, oh, this is for industry, this is for residential use, and so on and so forth. And when it's used for industry, there's a lot of contamination in the ground, so on and so forth. If you want to repurpose it, it costs a lot of money to clean it up and all this kind of stuff. If you shift a lot of the heavy or dirty industry off-world, now you have a lot more space on Earth to redistribute to use as you will, right? And so again, it's going to change, for example, the retail or the real estate industry of how we look at these kind of things. It's going to stimulate growth from an export-import aspect, right? Now you have a lot more opportunities to use raw resources outside that is pretty much limitless as long as you can mine it out, right? everything that we've been doing here on Earth is dependent on which country has that resource. And so that will limit our manufacturing capability and ability. Right? You look at the current big thing, which is rare earth elements between Asia, China, and the West, right? Who has the most, who's preventing who from getting what, and that really dictates, how our manufacturing works. And then, of course, one of the big thing is we're going to have a reduction in planetary environmental impacts because you're moving all these heavy industries, which is considered pretty dirty, off-world, at least some of it off-world, right? And so that gives you an opportunity to really increase your conservation efforts. Construction is going to be pretty much the same thing as the previous ones. There's a lot of companies right now that does construction equipment themselves. They have to look at how do we do this? What's available up there? Is the current designs of our equipment even usable in that environment? And we have to really look at it. But if it does work, you're going to have advancement in 3D printing technologies, like we talked about before. They're going to have their raw materials and resources right there versus having to be shipped to them. And then they're going to have to look at microgravity environments. Construction in a microgravity environment could be an actual plus, because now you don't need gigantic heavy cranes because it doesn't weigh as much, right? So these are things that could either help them or might cost them a little bit more in terms of research and development. But I think it's going to be an overall benefit. Then they have to start looking at, do we do this in an autonomous way, or do we have it teleoperated, or is it manned, right? Again, that looks at additional new markets for companies that does robotics, remote teleoperated systems, and so on and so forth. Again, there's a lot of geopolitical aspects to this. There's going to be either new companies cropping up that does construction specifically in the space environment, or do the new companies right now invest in and start looking at how do we expand our footprint into new areas and new market shares. And so that's either going to be a make or break for these companies. And I know a lot of companies right now start to think about it, but we haven't gotten far enough yet for them to actually really invest a lot of their time into it. So one of the easiest ones that we can look at right now is tourism. Everybody knows, right? Let's just go up there, what's that, Virgin Galactic and SpaceX sending some guys up there, some people up there. And so let's look at tourism. Tourism is probably one of the very first ones meant for regular people on Earth who isn't a 100% trained astronaut, right, in peak physical condition. So what are some of the companies or industries that's really going to need to service this? Well, the first one is going to be transportation. And this is where you see, Jeff Bezos and Blue Origin and all these other companies, Virgin Galactic and so on and so forth, really start to try to get into the transportation mode and make it more commonplace for people to really get up into space and enjoy it and make it an everyday occurrence, just like air travel it is to us today. And when you have transportation, we talked about earlier, a lot of different industries are going to crop up around it. You're going to need, quote unquote, spaceport, right? Whatever you want to call it at the time, but the spaceport's going to need support. They're going to need fueling. They're going to need all these other people. Just like you see in an airport, it's going to be pretty much identical from a transportation standpoint for people going into space. So then let's look at hotels. There are companies out there right now that's trying to build a habitat that will pretty much be a space hotel. And these hotels that are here on Earth, like the Hilton name brands and so on and so forth right now, are starting to look at these other companies who are building these hotels in space and see if they can do a partnership with them. right? Get their name brand up there because they don't have the technical ability, but they understand the service industry, right? And so now they're starting to work on some partnerships together. And this is only going to grow as we get into space more and more. So let's look at the other side of this. Now that you've got all the hotels, you've got the infrastructure, the transportation, and the service, well, people have to eat, right? So right now, the food that goes up there, man, it's not palatable. It doesn't look very good. It's just like a meal's ready to eat from the military, right? Not exactly, it may taste good, but it certainly doesn't look good, right? And so when you look at it from a service and a hotel experience standpoint, now you have to look at how do we get our food up there and how do we make it an experience that people somewhat recognize down here without having to squeeze out like a toothpaste, right? Because who wants to eat their food out of a toothpaste can? Nobody wants to do that. And so then we have to look at packaging as well, right? So current packaging companies, as an example, you can't send up cardboard boxes as of this time, or probably in any time in the near future. Why? Because it's highly flammable. It's got a lot of contaminants in it. You rip it, and shreds coming out everywhere. So we have to look at these companies that package the food. How are we going to do it? How's it going to get up there? How's it going to stay fresh, right? How's it going to maintain its appeal to the service industry and the hotels and the guests, while also maintaining health standards, right? And so these companies right here will have to start looking at how they do different things differently. And then there's the operations and maintenance side of the house, right? Where's the ground operations, mission control, maintenance? We're going to have to look at, clearing the way for space debris, which has always been an issue for numbers of years right now. And so there's also this side. And then when you really start digging even further down into the next level, well, these people who service this whole entire tourism industry, where do they live? Are they going to fly back and forth from Earth? That's costing a lot of money, right? And so we have to look at when they start living in space, then there's another economy that crops up around the people who work there, right? And so it just keeps going down and down, level by level by level, as you dig further down. And it isn't any different when you make the comparison here on Earth. Move to a new city, new industries crop up, people who live there crop up, more industries behind them to support what they want. It's going to be no different here when we get to space. And we just have to look a little bit further down, many, many levels down, to see the opportunities that's going to be available. So we talked a little bit about this packaging, food packaging industry. I'm going to talk a little bit about material sciences here as well, but the way that we package our food is really designed around logistics, is really designed around where the food's going to be stored, how it's going to be used, and all of that's going to change when you go to space. Either you grow the food in space or you bring it up from Earth. And so these companies will now have to start rethinking, oh, well, I do not have a warehouse within 10 miles of 30 supermarkets, right? So what do I do? Do I change the packaging? Do I work with the logistics guys to change this, right? I cannot use the cheapest method to package the food in a cardboard box now, right? Or whatever that they're using. They have to think about that environment that you're going to be in. Is it even allowed, right? Let's look at how that's really changed here on Earth. You look at cruise ships and air travel. Whole entire catering industries have cropped up around these. They have special chefs who knows the palate changes in a aircraft with high pressure environment, right? Your taste buds are lowered, so they put more salt in there. So there's a lot of different things that happen because of air travel and cruise ships. Look at how cruise ships manage their kitchen, how they get their food, right? It's not going to be the same as supermarkets, and it's definitely not the same as air travel. And so for them, all these new companies, these new catering services, all these new employees are starting to support each one of those markets. And it's going to be the same thing here when we get into space. And even now, the governments are working with certain, well, I wouldn't say certain companies, but there's a university, food sciences university, that they really work with in terms of packaging food for their astronauts, right? And these are things that, if we're really going to live and work in space, these are things that these multi-billion-dollar companies should really start looking at themselves. That's a potential way for a new market for them. And so we've been talking a lot about what are some of the materials that really go into this. Paper and cardboard is bad, it's highly flammable, right? Just like certain things that aren't allowed in a submarine because of high flammability and all this kind of stuff, it's going to be some of the same things that we look at in space. And these are things that when we work in the space industry, we're very concerned with: plastics, outgassing, right? Biodegradable materials, things that we're used to down here has different effects up in space, right? I'll give you a story here. We bought some cables from a company and we weren't sure whether or not they were space qualified. So what happened? We did not want to put it onto our vehicle. So we put it into a thermal vac chamber and we baked it out. And we realized it was outgassing, it was not space qualified. It outgassed so much that it contaminated our chamber, and we baked out that chamber for a whole week, 24/7, in order to clean the chamber. So if we sent that up into space, it would have contaminated all our optics and pretty much destroyed our vehicle. Something as cheap as some plastic, right? And so we have to start looking at materials that we say is okay here on Earth is going to have different properties than in space. And so we have to be very careful about what we use, right? Things that we say, oh, it's biodegradable here, so we're going to use that, but biodegrading is based off of biological processes down here. Not going to work in space, right? And so your biodegradable here is going to be one of those, never degrading pieces of trash up in space. So now something good down here doesn't work up there. And so these are things that these packaging industry people will have to really start looking at to do research and investment of what is the best cost-effective method to packaging these new products going up in space. Because today's world, the way that they package supplies that go up to International Space Station is on one end of the spectrum of being extremely expensive and not sustainable from a capitalist point of view. You don't want to go to the other end, which a lot of current industries are, where they're trying to cheap as possible but still maintain regulations. You need to meet somewhere in the middle, currently based on our technology and where we're going to be going. And of course, that will change depending on how things change in space. So this isn't going to be completely set in stone. This is just a snapshot of where we are right now. So one of the biggest things, every single one of these industries that we've been talking about, is all dependent on logistics and transportation. None of these right here will survive without their supplies, without their equipment getting to where they need to be. It all depends on logistics. How do we get the stuff up to space? How do we get the stuff back down to Earth? How do we get people up there, back down, so on and so forth? How do we get equipment to the moon? How do we get equipment to asteroids? Whatever it might be. Logistics is going to be the way. Each one of these different industries we've talked about previously is going to require something a little bit different, right? Transporting raw materials is going to require heavy transports. Energy is going to require different sets of transportation. Right? Manufacturing, tourism, packaging, all of these are going to be a little bit different. And so these logistic companies can either start looking at how do we do this, and is this something we want to get into, or other companies will come into place and take over for that portion of the new market. We talked about that already. And then one of the things that we really lose and don't really talk too much about is in these last couple of years, we've always been really, really concerned with, oh, here are all the big projects. These are all the fantastic, great marketing, big projects like getting to the moon, getting to Mars, getting to the space station. So the I guess, big marketing ones are, what's the software systems that are going to manage these, right? Because every single piece of equipment, every single thing that you bring up and down of there is going to require some kind of system to manage it, not just from a logistics standpoint, but you have to also look at traffic management as well, and so on and so forth. So there's a lot of different softwares that's going to pop up to really manage a lot of these different things, because again, a lot of the current software is designed for our environment here. So it's going to be a different environment, different time frames, different lengths, different things you're going to want to need to see, different things that you're going to want to make sure that you record, such as say food, for example. Over here, you're not so concerned about radiation. When you're getting into space, you do want to matter. It does matter how much radiation your food is getting, right? And so there's a lot of different things that we have to think about. And one of the most important ones is going to be navigation and communications. Everybody is used to GPS. We're like, oh, it's fantastic. GPS is designed here for terrestrial. And so there are companies out there right now that's looking to build an entire GPS system around the moon, right? Because as you colonize the moon, people are going to want to know where they're at, where their equipment's at, where their people's at, and so on and so forth. So they're looking at, do we build a planetary GPS system on whichever planet we're on, right? But the first one being the moon. But we also have to look at beyond, right, for deeper exploration, right? This navigation system, we're going to need to know a little bit more real time than we had before, right? You look at the Voyager spacecraft, that's way beyond our solar system now, right? A lot of our current navigation systems are pre-programmed. So it's pre-programmed in. If something happens, it comes back, we have to send some information. They cannot figure it out themselves, maybe in a rudimentary standpoint. So we have to look at what are these new types of navigation systems? Where does it need to be placed? What kind of systems are in there, right? Either whether they be emergency beacons and so on and so forth. So let's look at some of the systems here on Earth. You take ships, for example, many years ago, right? Lighthouses. They're non-existent now because why? We have GPS. But before, that was their emergency and navigation beacon were lighthouses, right? Same thing with air traffic control. And now space. It's going to be the same. Communications and connectivity. Communications isn't going to be immediate. Pick up the phone, you're going to be able to answer. It's going to be minutes right now, right? Even from the moon. You're going to say something, it's going to take a little bit for them to communicate, right? So we have to look at what needs to be real time, what can be delayed, and so we have to look at this communication system because it's going to be used for everything, for safety, emergency use, regular business use, so on and so forth, right? You want to be able to have real-time connection. You want to have solid communication and connectivity, because you don't want to be halfway into your discussion or an emergency system and it cuts off with buffers, right? Same thing here. That's why we keep upgrading our home internet systems, right? Because we don't want dial-up anymore. It doesn't work for us, right? We don't want cable anymore. It doesn't work for us, right? We'll take fiber at this point. And this is probably one of the ones that isn't talked about that much, but there's a lot of discussion right now in the background about potential bandwidth shortages. There's a lot of bandwidth that's determined by governments of who can use what and how much of it. And so as certain industries grow, the limitations or the rules that were set in place before will have to be reevaluated because the bandwidth grows, right? And there's a lot more people being used in there. And so it starts to be very, very busy. And so they have to look at, what do we do with this, right? When we're in space and new markets are there, a lot more people are going to be up there. How does that affect our current bandwidth usage here on Earth, right? Or is it an entirely new system? And so these are things that you either adapt for companies in the telecommunication industry to adapt and start looking at this, or again, new companies will come in and take that market share. We've been talking a lot about how do we get up there, what do we use up there, but how do we really maintain? How do we keep living up there? How do we make sure that the environment is the best that we can have it for what we need to do? We don't want to just go in without having a maintenance plan, right? From everybody here who's worked in the corporate world, and I've seen this many, many times myself, is somebody introduces a brand new project, a brand new system, and this is going to cost me $15 million to implement and buy. And I always ask them, what's the cost for maintenance over 10 years? No one has an answer, or they don't want to answer it, right? If you don't maintain it, the system is worthless in a couple of years, right? Everybody's scrounging for money to try to maintain the system, right? And then it becomes what we call band-aided, and then the system just goes away and then another one comes into its place. So how do we maintain this ecosystem? Space traffic management, right? Before this, if you can imagine, airplanes just flying whatever route they want, at whatever level they want. Just imagine that. It's going to be complete chaos. And you're going to need the same thing up in space. I mean, granted, the US Space Force right now has had some sort of system to monitor traffic and or debris up there for quite a while, but it's going to be a lot more robust, more like an air traffic management system. New routes, right? Right now, a lot of routes and a lot of orbits and all that is predetermined for the space station, for satellite systems that's going to be up there for many, many years. And now you could potentially have, you know, for lack of a better term, truckers, right? People who deliver logistics. Where do they go? What routes can they use? Where can they avoid from getting hit from space debris and all this kind of stuff, right? So these are kind of things that the new systems will have to take a look at, is what areas do we keep clear for this or that? And as a good example here, everybody's driven the freeway in LA. Trucks are not allowed on a 110 or certain freeways on certain hours of the day, right? Because that's for commuters. Outside of heavy traffic hours, then trucks can come in. And those are the kind of regulations that eventually we're going to have to start looking at. What do we do? Carpool traffic, trucks only lanes, so on and so forth, right? As a good an example here. And this has been one of the big ones for the last couple of years, and it's growing. How do we clean up the trash in orbit? There's a lot of companies out there right now that's trying to solve this issue of debris in space. Not even just companies, but a lot of universities and a lot of students are trying to come up with ideas themselves of what they can do to help clean this up. And again, this is going to be another non-flashy industry as a comparison. Right now, you know, the woman who started waste management, who collects our trash, is a billionaire, collects trash, right? Industry. May not be flashy, but it's an industry, right, that we have to look at, and it's absolutely a necessity for us. Okay? Like we talked about with the other three, without established rules, you're going to have chaos. You have to have common rules. And without these common rules, people are going to do what they want to do, especially when it comes to private corporation, when it's all built on profit, right? Or what people are going to want to do. So if there are no repercussions for what they're going to do, they're going to do it. Why not, right? And so this is what we have to look at. And that's what leads to a lot of these agencies are going to need to do a bit of an overhaul and a rewrite of what exactly they manage and maintain today and how it relates to the space environment, whether it's Department of Transportation, whether it's the Occupational Safety and Health Administration, so on and so forth. They're going to have to reevaluate and look at what they're doing. Because again, a lot of the companies right now, a lot of the space travel right now is done by the US government. So the US government, quote unquote, we police ourselves, right? And based on the number of regulations that NASA has, I believe it, and then some, right? So let's talk about governance a little bit here. Over the years, when Sputnik started and the Apollo program really came into play, they developed something called the 1967 Outer Space Treaty. Broad guideline, just a guideline of how and what space should be utilized for, based on that snapshot in time, based on what they knew, based on their culture at the time. That's what's happening. And as you can see, from that point to the present, there really hasn't been any kind of an update. And the reason why is because it's been mainly just government organizations. The governments can talk to each other. And so, they have some political leverage, and then they can try to work things out together because they know that one country cannot do it all. So they're going to have to try to work together. But now when commercialization is really coming into play, Artemis Accords are written. Now, again, these Artemis Accords is a refinement. It's not something completely brand new, but they're adding in some new things to it, right? Where they're adding in wording for commercialization so that we can gain some kind of normalization of being in space. Right? Again, just guidelines. And so you can see a lot of countries have signed up to the Artemis Accords, but there's a number of countries that's missing from it. China, Russia, all these other big players, and they're going to do what they want to do, okay? And so again, this is one of those where, okay, we have to work with all these different countries, but this international space law and governments and legislations, and licensing and permits and all that kind of stuff, what does that mean? We don't know. It needs to be written right now, right? Because theoretically, no one can own any planet. Resources are free for all for Earth. But again, corporate, other companies, private or public company, whatever, you go up there, they're going to own it. So from a liability standpoint, who owns what? Do I have permits to do this? Do I own that? So on and so forth. So we have to start looking at all that kind of stuff. We talked about the safety standards. What are the regulations? And what's the accountability and transparency up there? These are nothing different that we haven't seen down here on Earth. Right? We just have to apply it to a brand new environment. As we evolve, this industry completely evolves, and all of these accords and or regulations will evolve with it. And this isn't even really including what the United Nations is trying to do themselves. And so you have all these different bodies and groups have their own types of quote unquote regulations on how space should be used. But if we're going out to space, we're becoming one, living in a vast environment. And we have to start looking at how do we kind of come together to have a safety standard going forward, right? And the same thing here with aircraft. If you really look at from an aircraft perspective, from air travel, there's certain reasons why certain airplanes and certain companies are not allowed to fly into the US because they don't meet the safety rules, right? And regulations and maintenance and so on and so forth. And so these are things that we have to look at, same thing in space, right? It's for your safety. Other countries don't see it that way, and so then they don't do it, right? And we have to look at how does that work in a space environment. So how do we make all of this work? All of this is really going to end up being an education standpoint. How do we educate people and make it a normal everyday topic? As though, hey, I'm going to go to San Francisco for the weekend. Same thing. How do we make it that normalized? How do we do it? We have to educate at all different levels. Whether you're in elementary school, all the way up through high school, the university levels, you're going to have to make sure that this is part of their curriculum and that the curriculum that you're teaching is actual real life things and not just theoretical. Okay? A lot of universities like to teach theoretical. I went to USC, highly theoretical, not much hands-on. Other universities are more hands-on. So we have to look at what do we do and what's that curriculum going to look like. We do want to encourage hands-on learning because the best way to learn is being hands-on, right? Reading some books is great to get the idea through, but until you actually get there and do it, it's going to be completely different. And we talk a lot about curriculums in universities, but there's also a lot of different other ways that we can talk to aspiring people who love the space industry. But there's also clubs. There's also outside events that you can do yourself or join that actually helps in this kind of environment. Like I'm working with the Cal State Long Beach team with their CubeSat, and they're outreaching to high school students to kind of get them involved in what they're doing as part of an educational outreach themselves. And so those are the kind of things that we should invest more in, because these are things that students have come in themselves to start. It isn't a prerequisite for them to graduate where they have to do it. This is what they want to do because they're very interested in it, and we need to support them. Okay? There's a lot of people who don't know where to go to talk to somebody. So there should be more mentorship programs out there, not just, oh, I work in a big company, so just talk to the mentors within the company. Well, people outside the industry, I know a lot of people outside the industry who is very interested in space, but they have no idea who to talk to or what to do or what to learn. My friends are lucky because a group of us work in this industry, so they can always talk with us. But there's a lot of other people who don't, right? Even teachers. I've gone to events where high school teachers and other family members and all that, they love space, but they don't really know much about it. And so those are the things that we can do better to help clear the air on that. And like I said, make it an everyday topic for them. And then we also did talk about training, but we have to look at training from a different perspective. I'll take the medical industry again. Medical industry is just concerned with terrestrial, right? What does it mean in space? So medical schools, so on and so forth, will have to reevaluate how they teach, what they teach. Is the same methodologies going to work in space or not? And if it doesn't, what is the new methods? How do we teach that? And so on and so forth. In addition to that, with new methods that come in, these medical schools can say, hey, the current tools don't work. So then you got to work with medical device companies. Hey, I need something new, right? These are going to be the new standards in space. And so again, this continues to expand out even from a medical industry perspective. And one of the last thing is we have to utilize our media and outreach events. We have to change the perception is changing right now, which is fantastic. But there's still a bit of a stigma that, hey, science for geeks, that's not cool and all this kind of stuff. But it is changing right now. And so we have to continue to push forward to say, hey, there's a lot of different things that we can do in there, and it's not just for engineering and so on and so forth, right? We have to expand and broaden our view and horizon so that we do make it interesting for everybody. And somebody always has something to contribute to this. And so when they do feel when they feel like they're part of it, then they'll be more apt to stay in it. And again, it's no different than if you're at work. If they ask for your opinion, and they take your opinion and they try to utilize it, then you feel like you're being heard and you're more apt to stay there and not be upset. Everything that we currently do here today on Earth, how we teach people, how we operate our regular lives, how we interact with our environment and our ecosystem, it really is not that different than if you move into a new market share. Move into space, you just have to tweak some things because some things will be different, but it isn't any different than how you operate your daily lives here on Earth. And that's how we have to start looking at what space is. Beyond the flashy programs, I landed on Mars, now what? Right? I got to the moon, now what? Right? What do we do with it? Otherwise, we're going to end up right back where Apollo is. We got to the moon, done for the next 30 years, right? So we have to look at what do we do, how do we capitalize this going forward? Okay. That's pretty much my presentation. Is there any questions that anybody has? These are top level, by the way. We can go in depth on a lot of them. Yes.
At the very beginning, you had two slides. One was showing 2023 with $15 billion being used for something, and the other one, the next slide said 2023, $450 billion. Can you just describe what those two?
Sure. Yes. Okay, so this one right here is for launch providers, the first one. Okay, so the first one is launch providers. In 2023, it was about $15 billion market share, and as SpaceX continues to ramp up, especially with their Starship and all these other smaller providers at not just the heavy lifts, but the medium to small lifts, the industry is going to continue to grow because they're going to have more launch providers.
So that might be the total cost of all launches in
Yes.
Okay.
Yeah. And then this one right here is pretty much how the space economy is going to grow. So all the other industries that really support either those launch providers and or industries that are specifically designed to be in space. And so you're looking at an exponential increase as you keep going, as you can see, right? As long as launch provider and the interest in space continues, right? The economy will continue to grow. And as you saw in Artemis, of course, it isn't just in the United States, right? These are countries all over the world. Japan is putting some massive money. UAE is putting in massive money, to put in. China is putting enormous amounts of money to really get into space because they see the potential of it. All right. To answer your question. Any other questions?
AC online, he has a question. He can speak up. AC,
Okay.
Please speak up.
Yes. Okay. Hello, can you hear me?
Yes, I can.
Okay, thank you. Yeah, I'd like to thank you for such a thorough, fine overview of the subject matter. Just because yesterday I actually experienced the theft of a catalytic converter from one of my vehicles. I got me thinking about what I would categorize as I don't know, space crime. I mean, sooner or later there'll probably be the the first space murder.
Yes.
Will there be things like dedicated space penitentiaries? What about something like space piracy? Will that be a thing?
Absolutely.
What thought might be given to? to this kind of phenomena. I mean, for example, in the early days of the gold rush, once you have populations in space, what kind of communities might be sort of would arise with with the sort of various uh, uh, things provided for the miners and so forth. Anyway, it was just a thought that occurred to me. I'm just curious what kind of thought might be given to these
Yeah,
potential.
you're absolutely right. This presentation did not really cover the social aspects. It kind of, skirted around the edge of it. But you're absolutely right. These kind of things will happen, for sure. It will happen. You can see it here on Earth. It's happened. It will definitely happen in space. And this is where we have to start looking at some of these regulations and rules, and not just beyond the governance, but also, like I said, from a criminal justice standpoint. What does that mean? Who has jurisdiction up there, right? You've got to determine all that. Over here, it's either state or federal or Interpol or whatnot. What does that mean up there? Who knows, right? If it happened on your base, maybe it has your country's rules. I don't know. And those are the kind of things that absolutely will have to be thought out, right? So that's a very good question. There is definitely a social aspect to it, and there are definitely industries that really cater to all of that as well. Like I said, police enforcement, jails, and stuff like that. There's always going to be a lot of that. So you're absolutely right. There's definitely another market share in that part of in that part of the realm. That's a very good point. Thank you for bringing that up.
Tony online has a question about space police. Tony, do you want to speak out, Tony? He said he's a police commissioner studying policing and.
Hi, sorry, I'm having a little bit of trouble talking
Oh, we
or
can hear you
using
now.
my phone.
We can hear you now.
Perfect. Yeah. I just joined the meeting, but you are talking about something that I do. So I'm a police commissioner for the city of Eugene in Oregon, and that's actually something that I've been thinking about. Is I think we need to do more. I'm trying to do more exploration on how it works here on Earth, and then thinking about how that would work in space. Mostly, like I said, I just joined the AIAA, and I'm hoping to see, because I also come from an architectural background. I'm an architectural designer, and I'm kind of thinking about how the spaces up there would work, but there's so many different kinds of designs that people are making, and I don't know what the standard is. And not that there needs to be a standard, but maybe kind of seeing some of the common threads that we have in the spaces up there would also influence like how it is that we can provide security for people. And just it's interesting to think about how the police coordinate themselves, and like how would you even coordinate up in space? Everything, at least in the beginning, presumably is like a lot smaller in scale. So then how do you not have like a space that feels like a police state, so to speak, but also people that feel secure, how to make people secure? So I mean, I guess what I'm getting at is more like I want to connect with somebody if anybody's been thinking about this as well. I'd love to kind of talk about this a bit more and explore it, and then we can talk about how my experience as a police commissioner for the last 3 years could continue to influence this, if that makes any sense.
Yes, absolutely. Very great point. Actually, I've thought about some of that. We should definitely connect. We should talk some more about how the space economy and how living in space is going to work from a social perspective. That's a very interesting topic to me as well. But you're right. We have to strike that balance of how much policing is necessary up there, because today's world, again, it's government regulated. These are government employees. They're trained to be, they're probably former military, so they are highly disciplined in terms of their integrity. But again, when you start moving further and further away from that, because they're self-policing at this point, not to say that even that doesn't, things happen there, but as you start to move some of that away, then you bring in a lot more risk involved. And this is where you were saying, Bonnie, is that there's a lot more opportunities now for potential piracy, theft, bodily harm or injury of other people up there, depending on whatever the issues are. And we have to strike that balance of what are the rules up there, how it's going to be governed, who's going to govern it, right? And what's the jurisdiction and what is it going to look like? Now, granted, there are certain laws down here that can easily be applied up there, broadly. Hey, don't murder somebody, otherwise, this is going to happen to you. But for other things, what does that look like, right? And so you're right. It's a very big issue that needs to be looked at as well. I'm not sure many people have been looking too much into it. So I would love to talk with you some more and really explore that idea, especially since you're, in police commissioner world. So that would be fantastic.
Yes, so if you want to put your email in the chat, I'd love to contact you. My email is already there, just so you know.
Yes. Hey.
Just wanted to piggyback on what you were saying about governing. Since nobody really has jurisdiction up there, is there a chance that we might see like a separate governing, like maybe like a world government emerge because there's no jurisdiction? And
so that one's, in my view, that one's probably going to be a little bit hard. It's great to say yes, but in today's political environment, I doubt that's really going to happen anytime soon, because our thought process currently today is that we're all in our own little world, and we want to make sure that our little world is the best world, and we're going to make sure everybody else agrees with me, right? And so because of our cultural perception and the way that we look at ourselves, it's probably not going to happen for quite a while until we start exploring further and further out, where Earth starts to look smaller and smaller and smaller, that we just become, oh, okay, maybe they should be one government, right? Because there's so much more out there. So I think it will take some time, but it's not completely out of the realm of possibility.
it seems like it may be hard for governments to police each other up there because, for instance, like you said, Russia and China won't sign the Artemis Agreement.
That's
They
correct.
notoriously are harsh cybersecurity.
That is correct. That's absolutely correct.
So when we talk about like communications and things like that, if something goes offline,
Yes.
what's it take to actually even get to the equipment to diagnose it, to figure out what happened and to figure out who did it? And then,
so if you look at the snapshot of today's geopolitical outlook, these countries between the US, China, and, other foreign nations, they have quote unquote these hotlines to de-escalate potential situations. And in the short term, they're probably going to have to do something similar to that, right? Because at this point, everybody is fighting for dominance, right? And when you're fighting for dominance, you're not going to be really open to, hey, I want to work with you, right? And so this is where the system that we've set up today in terms of setting up these kind of political hotlines to ensure, we de-escalate situations, so on and so forth, will have to probably continue. And one of the great examples is, not recently, but a few years ago, in Syria, when the Syrians were trying to attack this oil field that the U.S. was protecting, right? The U.S. called Russia, hey, none of your guys are in there, right? No, we're not. So they went ahead and bombed them, right? So that's one of those, even though they were really there, but that was the hotline. And because they said they weren't there, they can't say anything after that, right? And so these are those kind of hotlines, the escalation hotlines, they're probably going to have to keep for quite a while. So that's the unfortunate outlook for this world right now. We have not yet come together and be cohesive into one environment. But great point.
Hey, Dennis, this is Martin McLaughlin. I don't know whether we knew each other at Northrop. I was there for 39 years.
Oh, okay.
But
I'm sure we cross paths one day or another.
We must have. Good presentation. What I would like you to comment on is the power requirements to go from 280 billion to 450 billion to 1 trillion economy. And it's not just electrical, a lot of that would be thermal power. And there's an economy of scale problem with as you move up, if you're just relying on solar energy at 1,300 watts per square meter.
You're absolutely correct on that. And so let me get down a little bit further here. Hold on a second. So that's a very good point. I did gloss over that real quick, but let's go back and talk about that a second.
I think it's essential. I think it's a prime mover as far as allowing that economy to grow.
Yes, you're absolutely correct, which is why I added in here also for advancement of miniaturization of nuclear and fusion technology, because you're right, it isn't just solar. There's going to be other kind of power generation systems and ways of getting power, because you're right. Solar isn't going to provide everything that's going to be needed by 2030. And so we're going to have to look at what can we do today and what do we have today to help supplement that until, if we decide solar is going to be the way to go, right? So,
well, and is it distributed or central or somewhat centralized on Earth? You know, we get huge economy of scale by having these, you know, gigawatt power plants. You know, solar you can have distributed. You know, that's fine. But I don't think every drilling outpost wants its own nuclear plant.
that is correct. And so a lot of that is going to be dependent on whichever industry is up there and how they lay out their system, just like you were saying, right? If it's a one-off outpost, they're going to have their own power generation one way. But if you have 10 different manufacturing areas or mining areas together, you're going to have a different power distribution system, right? So it's all dependent on your layout and what you actually have that you need power from a certain grid. So you're absolutely correct on that.
And just one more thing, one of my interests is thermal rockets.
Uh-huh.
If you could beam the energy from a centralized source, then you don't need any onboard combustion devices or a nuclear reactor. All you need is a propellant to heat up.
That is correct.
We don't see that on Earth, but really, well, I guess you do with electric trains and things.
Yes.
But so there's having power available, is beamed power particularly, enables transportation options that you wouldn't otherwise have.
You're absolutely correct. And that does kind of go into the transmission technology, like you were saying, right?
Right.
How do we get this energy to them? I mean, right now it's a matter of transmission over power lines or via battery systems and so on and so forth. But, you know, you take your phones, for example, right? Before, your iPhones were connected via USB-C or USB lightning cable, whatever, lightning cable. And now, what is it? It's just a docking port, right? Wireless transmission, wireless power. And that's
in vacuum, you got a lot more options than
that is correct. And so there are a lot of different opportunities. As you can see, all these people bringing up all these different ideas, and these are just expanding on just the top level that I have here. So there's so many different questions and so many opportunities for all these other industries that it's abundant for everybody to be a part of. Fantastic question. Thank you very much. Is there anything else?
Sudhir online has a question. Sudhir.
Hi, Dennis.
Hi.
Hi, thanks, Dennis, for that enlightening presentation. So my name is Sudhir, and I'm a former Boeing 777 pilot over a decade of flying who transitioned to software engineering after the pandemic. So I have a unique blend of hands-on aviation, airline flying experience, flying international routes, and I'm keen on identifying opportunities where my piloting background can be leveraged to develop space-based products, digital software tools, decision support tools, or basically innovations that also have a sustainability edge for this aerospace industry.
Mm-hmm.
I'm looking to draw on your decades of experience if you have any unique insights on what you would suggest how I could contribute.
The quickest one I would say right now is because you have so much experience in flying aircraft, especially international routes. So you've seen how different different governments and different systems work together to ensure safety of both hardware and people themselves, that your experience in the knowledge of what the operations are, how you operate internationally, domestically, even with Boeing, the manufacturer of the vehicle itself, those are operational information that a lot of people, such as myself in the space industry who has been building these things, don't exactly have, right? And so this is where a lot of these companies have to partner with people with that kind of industry, with that kind of experience, such as yourself, to say, okay, I have a product, I want to use it in space, right? What is the ideal, not ideal, but what is the best way to say, for a logistics standpoint, I want to build a new transportation vehicle. What are the things that the pilots are going to have to worry about? Or what is the system going to have to worry about, right? In terms of what does the traffic control system look like, right? What are the new acronyms look like, and all this kind of stuff. These are things that we hear from a top level, but we haven't experienced it in detail, such as yourself. So these are like areas that you can easily insert yourself into and provide input in terms of, hey, for say, space travel from a transportation perspective, these are my ideas that I think that we would have to look at further, because it would actually work in a space environment as well as here in terrestrial environment.
Thanks, Dennis. That's a great answer.
Thank you very much. And if you have more questions, you can always email me or get in contact with me as well.
Okay, thanks, Dennis. Yeah,
Sure.
I foresee that being a big need for adapting the complex navigation procedures, like you mentioned, communication protocols that pilots use to the space travel environment.
Right.
I think that many lessons can be learned. Thanks.
Yep. All right, thank you. Any other questions? Yes.
So given the limitations to the human body that you mentioned and their limitations to live in space now, and then you also mentioned $1 billion economy by 2030, which industries do you think will be the emerging, most thriving by then?
Most thriving by then? Based on the trajectory that we're heading right now, would probably be tourism, as long as you get the cost down enough for regular people to actually go. And when I'm saying getting the cost down, I mean down to a expensive vacation, not, hey, I got to spend half my lifetime, right, in order to do it. So if you get it down to that kind of a cost, I think tourism would be a very, very fast and quick and easy explosion in terms of growth. Because if you can go into, say, low Earth orbit, or just at the Kármán line for $5,000, I bet you millions of people will do it. Yeah. Right. And so that would be an explosion. If we're smart and we do it right and we get onto the moon from a mining and manufacturing perspective, I think that's probably another opportunity in itself. One of the programs that I worked on was L-Cross, where we crashed our satellite into the moon to look for water, and we found a lot of water, right? We found enough water to cover the whole surface of the moon by a couple inches, right? So if you extrapolate the data that we found, that's how much water is on the moon. So because you have those raw resources, you can manufacture your own water, you can split it, have hydrogen for fuel, so on and so forth, right? You can use the regolith as raw materials for building, and so on and so forth. So there's opportunities from a mining and energy and heavy industry perspective that I think would be probably the next boom. The highest terms in terms of return on investment will probably be the mining portion of it, as long as we're smart and the technology is there, and we continue pushing forward and not just doing it because it's the political flavor of the decade, right? We have to actually keep doing it because it's something that we really need to do to expand ourselves as a species. Okay. Any other questions?
I think because Shaheen online, he put some comment on, he can speak out. Shaheen, do you want to speak out? He mentioned something about
that was, oh yeah, I guess that was the earlier discussion about policing theft in space. I don't know a ton about this topic, but I had suggested maybe the way we govern international waters, with ships, either they're cruise ships or other types of transportation, could be an interesting kind of precedent example to look at. Like I said, I don't know a ton about the subject. That was just a suggestion.
That's a very good point of view. And just like you said right here, there's a lot of things that we've developed here on Earth that has great structure that we can expand on in space. So it's not that we have to build everything from ground zero, because being an engineer, I don't like to build something from scratch again, redo the wheel if I don't have to, right? So we have to look at, hey, what do we have here today that we can modify and adapt up there so that it becomes faster and quicker. So if you're trying to adapt something and modify something, it's a lot faster than trying to come up with something new. So that's actually a very good point.
It's cheaper to ship D9 bulldozers to the moon or create a whole new thing.
Right, that's correct. And so that's where they have to look at, is the materials inside the equipment or the bulldozer adaptable in space? Right, because there's certain materials that we don't want to use in space, such as like zinc and tin, because hot, cold, and a vacuum environment causes it to whisker. And so you hit a circuit and then you short circuit. And so that's why we have to look at the things that we have here today. Is it adaptable, or can we just change some parts and it's okay? Right, and so these are what the industries, the manufacturers will have to look at, is can their products be adapted to a space environment? If it's something as simple as, oh, I got to change out maybe 10% of the parts of this bulldozer, great, fantastic, it works. But if I have to change out 90%, I might as well design a new one.
Works for 5 minutes until it gets clogged with
rubber. That's correct. That's right. So that's what we have to look at. What we have today, can it be modified? If yes, fantastic. If no, then we have to come up with something. Because with that kind of thought process, that's how you're going to get companies and people more accepted into a space environment. Because as soon as they hear, oh, I have to spend billions of dollars to reinvent the wheel for everything, that's a no-go for just about every corporation, right? But if you start to break it down, say, hey, I can use this, we modify it, it's only going to be 15% of building something new. Let's talk about that, right? Your return on investment is going to be higher versus building something new. So we should definitely look at how we do things. And okay, so not to bag on Northrop Grumman, because I was there for many, many years, but I'm sure a lot of other companies do the same thing, where a lot of engineers, when a program first comes into play, everyone's like, I want to build everything brand new, everything state of the art. I can build it better, design it better, whether it's a support equipment or a brand new piece of flight hardware, so on and so forth. So the cost just goes through the roof until it gets to proposal, and they're like, absolutely not, we'll never pass, right? And so this is where I tell people, hey, I have a 500,000 square foot warehouse in Carson. Let's go down and see what equipment from past programs are there that's been abandoned in place that we can reuse. If it has been abandoned, let's get permission from the government or whatever program who doesn't use it anymore, and let's take it. Now you got a free piece of equipment that you have to modify versus brand new. Right, and so that's why we have to change some of the perspective from an engineering world, because we always love to build something new because that's awesome. That's what we went to school for, right?
Those aren't tried and tested as well. These bulldozers that are multiple iterations through 100 years of pushing dirt around.
That's correct.
That experience should come into play.
That's absolutely correct. And so there's the experience with the equipment and the new environment. And when you marry those three together, and those three industries or those three experiences work together, you'll have a working product going forward, right? If you just have one person who manufactures it that doesn't have the operational experience, like we were talking about with aircraft, right? Then we're going to design it with our best knowledge of whatever we read online, right? And it's not necessarily going to be exactly how it operates in the real world. Right. And part of the reason I do a lot of this outreach is because I see how like universities, and again, I'm not bagging universities. A lot of universities does have great people teaching, but a lot of students that come in don't have exactly a good realization of what the real industry looks like, right? I'll give you an example. I've had students come in to tell me, oh yeah, my senior project, professor told us, don't worry about cost, don't worry about weight, don't worry about manufacturability. I go, we cut functionality because of those things. Right? And so those things are actually important to us because we're here to make a profit, right? And so we want to adjust the expectations. So you need to have those three. People who have real world experience in whatever industry you're looking at, whatever product you're trying to modify, you need to have a manufacturer there. And of course, you need the people who have experience building that stuff and in the space environment. So you have those three together, who are open-minded, and you're going to have a fantastic product going forward.
I have a question. Do you foresee the development of sort of not necessarily not quite space travel and something beyond aviation, things such as suborbital transport? I mean the 40-minute London to Paris type suborbital type of transport. Yeah, the Concorde didn't seem to be financially too viable. And I'm just curious, perhaps now with the ability of SpaceX, for example, to just so precisely land those boosters back and so forth, if you could maybe develop this kind of sort of very high speed transport, intercontinental probably be the application here, New York to Sydney, New York to London, that sort of thing. And will that ever be actually financially, do you think, viable or?
Absolutely, I do. Because let's take Starship, for example. Starship has a multi-purpose, right? It can do what you're saying in terms of intercontinental travel in a fraction of the time, or it can actually go into deep space, right? And so Starship from a perspective is it has two different kind of roles so that it could kind of spread out its operating costs, because if it's not transporting people, it can transport cargo, right? The reason, in my view, that the Concorde wasn't really viable is because the technology never evolved, right? It was built back in the 60s and whatnot, and it has never changed since its retirement, right? And so because its one purpose was to just take high net worth individuals from one spot to the next, there's only very few of those, right? And those really high net worth, they have their own transport. So then they don't really need the Concorde. So this is part of the maintenance and evolving. If you just throw a product out there and say, oh, it's for this, and then just kind of let it go, it will eventually die and replace. If you have a little bit more forethought into products being multi-use, such as, for example, Starship, where yes, it can go into space, it can deliver passengers, it can deliver supplies, and when it comes back down, it can come back down wherever you want it to come back down, right? And so yes, it does have dual use, and the more uses that you have for it, the more you can spread out and amortize the cost, to other areas and or industries that you're supporting. So I absolutely believe that a lot of this stuff right here can, especially from a transportation perspective, can actually be used for, specific just passenger travel, as long as we continue to evolve. Does that answer your question?
Yes, it did. I tend to agree with you. I guess the sort of the economics of scale are definitely going to be necessary in order to make it affordable for say not necessarily maybe the average passenger, but maybe a little bit higher end, but not just quite as you said the extremely high end sort of privileged type of person that would be traveling in such a system. But yeah, I just don't know if any of that beyond Starship. I mean, I realize that's multi-use, but perhaps maybe a more dedicated systems just for this application, whether that would be feasible. Not necessarily something to the scale of the you know, as large as a Starship. I mean, I don't know what kind of passenger loads that might be able to carry, but something in the order of more of a you know, medium scale sort of aircraft. You know, maybe a, you know, 100 people or something like that.
Yeah.
Or if something in that scale would be feasible. So,
Yeah.
so it wouldn't need as much infrastructure as, for example, Starship. I mean, we all saw what that first launch looked like, and I just kind of shudder to think. As you know, I live near some airports and military bases, and just that alone is kind of a noise wise that's kind of impacts.
Yes.
And so I'm just curious what something like Starship would require in order for that kind of infrastructure that would impact surrounding, you know, populations and so forth, where you might want this kind of transportation available so that people could access it. So I was just curious in the general topic whether any perhaps thought had been given to a more dedicated system for those
Yes.
kind of orbital type of transportation.
Yes, there is. We're gonna get a little bit away from the space here, but let's talk about it. So I did hypersonic research for a little while with NASA, and that was, you know, with its own free flying body X-43A, really Mach 10. How do we get to Mach 10 to increase our travel, right? Reduce our travel time from one location to the next. There's a lot of research going on right now, and you know, I'm working with some startup companies, and I see some of the pitches that they have, and a lot of these new startups are looking at producing a quote unquote Concorde-like passenger travel without the negative effects of like the sonic boom and so on and so forth, and try to make it economically viable from a cost perspective, with very little footprint in terms of changing the infrastructure, just like you were mentioning there. So there are a lot of people out there right now, and this type of travel is almost kind of in the middle between air travel and space travel. And so it can really benefit from the technology of both to help that level of passenger transportation that you're mentioning. So one thing I want to mention too, and you just jogged my mind, is that a lot of these companies and a lot of these industries can leverage off of each other, right? And we should be smart about learning from each other. What did you learn? What works? What doesn't work? And how can I apply it to my industry or to a new industry? And so this is a very good example. Is you have something that aircraft, but you have aircraft luxury and aircraft passenger travel standards. You have spacecraft speed. How do we marry the two together to get something that gets us from a passenger perspective from one location to the next faster? So there are definitely a lot of companies out there that are working on that kind of technology.
Interesting to see when these spaceports start popping up. They're going to be in remote areas because space travel is very, very loud, right?
Yes.
And then people will start congregating around those
Yes.
areas and building businesses, and then that will
Yes.
draw people in, and then wealthy people will come and live there as
Yes.
well, and then they'll start complaining about the noise and try to get the spaceport shut down.
Yes.
Because
So funny you said that. So Virgin Galactic opened up a spaceport in New Mexico. I forgot the name of the town in New Mexico. I actually looked at potentially working there. And when I saw the town, it was literally one street with like 5 buildings. I'm like, I'm out. I can't do it.
Yeah.
But you're right. That's exactly what you're saying. They built a specific spaceport for wealthy individuals to go on this experience. So that right there is probably one of the very first quote unquote commercial spaceports.
I think it might almost be the opposite, where once people move there and they realize that that's what it is, they would be more accepting of it elsewhere because they visited there and they're like, oh, yeah, they hear a lot of booms.
Yes.
I visited there and I heard the booms, and
Yes, that is
everybody has
correct.
thick windows or whatever
Yes.
it is.
And so this is where also the government regulations have to come into play. So anybody that lives down by John Wayne Airport, they realize that when you take off, you have to go at a steep angle because you can't fly over the houses, it's too loud. So they want you to go up and really high. That's why LAX, you just go over the ocean, no problem, cruise, take your time, right? And so those are the regulations, like you're saying. If there's high noise environment, then we're gonna have to look at how does that affect the people around them, right? Or the environment.
Once you have to build in building codes that say, hey, you're gonna need this amount of noise abatement because it's in your Mello-Roos or whatever.
That is correct.
So you just, you sign a waiver that by living here, you just know there's gonna be sonic booms every 5 minutes.
That is correct. That is absolutely correct. So when I built the new facility over at Northrop, that was definitely a lot of rules that the city has set for us that we have to meet, right? You can't pump out so much gas, you have to have all these filters, the smell, and because there's residential within so many yards of where you're at, you have to do this, not so much noise, and so we have to build in a lot of different containment systems, environmental systems in order to meet the rules set by the city.
What facility was that?
M1, M2.
Oh,
so in the
okay.
back, you have all
M1.
this. Oh, okay.
Yeah.
I redid M1.
Oh, cool. Yeah.
So
cool.
yeah, M1, M2, all of the factory modernization stuff.
Were you responsible for the cubicles?
Yes. So don't knock on. Wait, on the second floor?
Yes.
No, that's not me.
Okay.
No, that was not me.
Okay.
That I won't say which executive decided that, but I was not supposed to touch any of that, and they were supposed to be as is. I built the cubicles in a classified bay.
Oh, okay.
On the other side.
Well, when we did the composite center,
I'm sorry, what was that?
when we did the put in a new autoclave in the composite center in El Segundo, we couldn't get a permit for an emergency diesel generator in case the power went down.
Yes.
And you got to be kidding me. It's something that's used once or twice a year. And it's not safe to have an autoclave without electrical power. So so that was kind of crazy. Along these lines, just to interject for a minute, I've been working on suborbital boost glide transportation, not for people, but for critical cargo and also ISR. And that's got a lot of potential, and it doesn't, and like Virgin Galactic, if you air launch it, you don't have the ground launch rocket noise. That's up in 35,000, 40,000 feet somewhere, and it can be off the way over the water or whatever. So that's interesting. Putting people in it's a little harder. If for a boost glide trajectory, it's tough to get the G's less than 5. You can, but it's tricky.
Yes. Yeah. When I did the X-43, that was we lifted up onto a B-52. We dropped it because we were strapped onto an orbital rocket, right? Boosted us up, and then we separated, and then the glide of the vehicle itself took off with the scramjet. So you're right. It does. You will have a problem reducing the number of G's, but a lot of these technologies that we talked about today, and even just verbally, I haven't even talked about the military aspects of how they leverage all of this as well. A lot of this technology, like getting equipment and supplies from one place to the next within 30 hours, that's something that they absolutely want, right? Because then that means.
Well, one of the lessons learned from Afghanistan was and Iraq was the cost of transporting diesel to the forward operating bases. You just had convoys and convoys of tanker trucks, which are perfect targets for insurgents.
Correct.
So, there's a certain. I believe that 20 years ago, overnight delivery was, everybody laughed, and now you get $10 items delivered overnight.
That's correct.
Now, a 1 hour delivery from Anchorage to Taipei City can happen.
Right.
And it might be something really important.
Yeah. I mean, imagine 15 years ago, overnight delivery. What?
Yeah, people laugh.
$100. Now it's $20, give or take, depending on the size of your package.
Wow. Well, and things that are not high value, low cost items are delivered overnight. It's amazing.
Yes. And when you work on these transportation and logistics issues, What that does too is the ramification is maybe you don't need to have as many warehouses nearby, right? Because you can deliver it faster.
Yeah.
Take from a military perspective.
No, it's
You have 300 military bases around the world. If you can get it from the U.S. to wherever, anywhere in the world in 30 minutes, just ship it to the U.S.
Well, it's the conveyor belt theory. The faster the conveyor belt goes, the lower the loading on it.
That's correct.
So you need less of everything if you go faster.
That's correct. The whole point now is how do you slow down? Yes. All right, fantastic. That was great talk. Any other questions?
Yeah, Robert and James has question. Robert, go ahead.
Yeah, the challenge, we were talking about suborbital resupply. The challenge with that is I've got something that's basically on a ballistic trajectory coming at me. How do I know it's a package and not something, or not a warhead?
You're
Well, at least in my case, it's a space plane and it has nothing like a ballistic trajectory. It's surprising. You put wings on a rocket and you really want to fly it. And so it doesn't look like, we had that problem with Rapid Eye. We were using surplus peacekeepers to deliver an ISR platform, and everybody said just what you said. Hey, this looks like a nuke coming in. But you can make it to where it doesn't look anything like a nuke.
Yeah, and so
Okay.
so this is where you look at, a lot of military satellites are monitoring. So if you are launching this thing from a known silo area, then yeah, you're going to set off big alarms everywhere. And just like you said, you can always do things where, hey, don't send it from someplace that is known to be, have nuclear weapons and so on and so forth. Put it in a different kind of trajectory, put sensors or beacons on it to say, hey, so on and so forth. That's not to say that, it covers every aspect of, weapons delivery, but, kind of diverging off topic a little bit. But yes, there's many different ways that you can put stuff onto a transportation vehicle and have it not look like a weapons delivery system.
There's also a little logic problem there. I mean, if you were doing a first strike nuclear attack, would you do it with one vehicle? I don't know. Maybe if you were a terrorist. I'm not trying to belittle the concern, but you wouldn't be. I don't think it'd be a single rocket in something like that.
That is a whole other conversation. Does anybody else have any other questions for me?
I guess it's my turn.
Oh, go ahead.
Basically, have you considered the impact of an internal and external economies? What I'm thinking of is a community on the moon meets 90% of its needs through local resources, but then it has that last 10% that it has to import from the Earth. And to do that, it has a product that it can sell to the Earth, in which case it's very motivated to make that product economical.
Yes, you're absolutely right. That's pretty much what these new markets and economy is going to be becoming when it crops up. Who's not to say that you don't find some kind of mineral out there that is not found on Earth, right? And that's a new resource that could be shipped back to either Earth for processing or use, or to on the moon or Mars or wherever. So there are definitely options there. Corporations who set up bases or manufacturing facilities either in Earth orbit or on the moon, planetary surface, and so on and so forth, they will be creating products to be self-sustainable, but they're also going to be creating items that they can use themselves in space and or ship back on Earth. So that's going to be the whole that's going to be one aspect of the whole kind of space economy and the new markets that's going to be cropping up everywhere. But that's a very good point. Any other questions?
Just have some more time. There's one question in Q&A. You cannot use the microphone. The CubeSat.
So this is for CubeSats. Okay. So from a CubeSat perspective, CubeSat's a little bit easier because there's a lot of training out there. If you're in a university level, if you go to the San Luis Obispo CubeSat website, they have a lot of great information, a lot of great people there that can help you to get into what CubeSats do. From a software standpoint, software is going to be really dependent on what the mission is going to be. If you want to get into software itself and into satellite systems, of course, you're going to have to understand how to write software and coding. Short of that, getting into certain companies, like the traditional aerospace companies, to help you develop the skill sets. Even Raytheon or any supporting companies that develop test set software, if that's what you're interested in, versus flight software. So you have to look at which ones you really want to do. And now there's companies out there that's branching off and not doing so much just test set software and software for flight software, but there's companies like, take Amazon, for example, and there's a couple of other companies in Europe that are starting up where they're providing services of ground station services for satellites. So you can actually work for these companies like Amazon and all these other startups who are providing ground station services, and they will need software people to develop the software systems in order to operate the ground systems and communicate with satellites. So there's many different ways. As you can see right now, even companies like Amazon are trying to get into this, right? Right? They just launched their own set of CubeSats or communication satellites. So everybody's expanding quickly.
Yeah, I wanted to point out, you mentioned earlier the problem of the bandwidth limitation issue in terms of radio communications, and I'm aware of this latest NASA mission, the Psyche mission that's going to be going out to the asteroid near Jupiter. Yes. That actually have on board a laser communication unit that will be used for interplanetary communications. Yes. So this might actually provide a solution to the microwave and standard radio communication sort of bandwidth problem if it's successful. My problem is with Earth communications is, well, what happens on a cloudy day, and you really need to get that data up or down to the unit, to the satellite. Right. So it has its problems, but I think it could certainly reduce some of the impact to the bandwidth limitation. So that might be one possible solution.
Yes,
to that.
You're absolutely correct, and this is where, when you look at the whole entire system, let's just take Psyche for example, and if you have a whole system of navigational beacons or communications arrays and so on and so forth, right? You can have Psyche beam that information to a communication array that's in orbit of Earth, and if you want to make sure that clouds and line of sight and all that kind of stuff doesn't interfere, then from that communication, it can go into regular transmission methods, right? That isn't affected by that. So there's many different ways that you can utilize this, right? So you have to look at what is the mission, what exactly you really want from this, and then you can put together a system with multiple technologies that works together into one system that gives you the kind of reliability that you're looking for. But yeah, that's a very great point. Anything else? No more? Okay. I think that's it, Ken.
Thank you. So that's Rob Pro. Yeah, one thing is we did prepare appreciation certificate, but unfortunately because we are going to Las Vegas, so I packed in my car.
No problem.
So next time, October 28th,
yes.
Right? We'll present it to you. No,
yeah.
November 4th is your presentation.
Yes, but I'll be there on the 28th.
Yeah. So we'll give it.
Okay.
So really appreciate it. Thank you. Wonderful talk. I thank you everybody for being here. So our next event, as I mentioned, is the October 28th in Lomita Library. Is the company called Gitai. They designed the robot system. It's a local company, and it's a company who got the NASA contract to do the on-orbit servicing for the International Space Station. They will do some simple demo. Their senior manager is going to give a talk. And then November 4th, as Dennis was here again talking about the digital frontier, very ultra exciting. So the next event after Dennis talk on November 4th will be our young professional networking event. It will be in the Common Space Brewery right next to SpaceX. So please join us. It's November 14th. November 14th. And there is we're just working on another event we haven't sent out yet, which is also very interesting. Is by JPL chief scientist is Dr. Randy Wesson is going to talk about the future of U.S. robotic planetary exploration. Right now, we planned it for the Long Beach downtown main library. If you've been to downtown Long Beach, that's a business area, so it's right next to convention center. So, so please join us. If any question, please let us know. So thank you, everybody, online and in person here. So have a wonderful day and weekend. Thank you.
Thank you.
Okay.